Welcome everyone. In this video, I am going to discuss Leibnitz rule for differentiation under integral science. This has wide application to solve problem of definite integral. It is not included in our board syllabus, but it is useful for solving Layman and IRT problems. So, what is the rule? Before we solve problems, so what is the rule? So, d dx of integration phi x to phi x ft dt. So, integration with respect to t and upper limit, lower limit in terms of x. So, it is function of x. So, suppose this is capital X. This is capital X. Now, what is its derivative? Here ft is continuous function. Now, fx equals to, so if we differentiate it, then integral sign will be constant. So f of phi x, t is replaced by upper limit, then derivative of upper limit, that is phi dash minus f of lower limit, derivative of lower limit, that is phi dash x. So, listen again, d dx of phi x to phi x ft dt equals to f of phi x, t is replaced by upper limit, then d dx of upper limit minus f of lower limit, d dx of lower limit. So, this is general. For particular value, suppose fx equals to 0 to x ft dt. So, if it is 0 to x ft dt, then what is f dash x? F dash x means d dx of integration 0 to x ft dt. Now, this one is f of upper limit. Derivative of upper limit is x, derivative of x is 1 minus f of 0 d dx of lower limit. Derivative of lower limit is 0, so this is fx. So, it is particular case. So, if fx equals to this, then d dx of fx, d dx of this, we are considering this as fx. So, it is d dx is already given. So, it is fx. So, this one. Now, we apply this theorem to some problem. So, look. So, these are basic problems. So, problem number 1. 0 to x ft dt equals to x plus x to 1 t ft dt. Find f1. Find f1. Now look, we do not know form of fx. So by ordinary method, we cannot find its value. So we use Leibnitz theorem. So differentiating both sides, with respect to x. So f of upper limit fx ddx of upper limit is 1 minus if lower limit is constant, so minus 0, so limit, and derivative of x is 1, and this is ddx of t into ft. So 1 into f1 into ddx of 1, that is 0, minus x into fx. Derivative of x is 1. Now, what is our main aim? Find f1. So fx common 1 plus x equals to 1. So fx equals to 1 by 1 plus x. So what is f1? f1 is half. So look, we do not know form of fx. So but we can find value of f1 by using this. So similarly, problem number 2, 3 all are same type of problem. Suppose problem number 4, 3 and 4, 100% same. So problem number 4. Cos x to 1 t square ft equals to 1 minus cos x. X belongs to 0 to pi by 2. So find f of root 3 by 4. So again we do not know form of ft. So we cannot integrate. So this differentiate with respect to x. So t is replaced by 1. So 1 into f1 into 0 because upper limit is 1. Then cos square x into f of cos x into minus sin x. Derivative of cos x. Cos square x, f of cos x. So t is replaced by cos x. Now again derivative of cos x is minus sin x. So derivative of 1 is 0, which is plus sin x. So finally, cos square x into f of cos x equals to cos square x into f of cos x into sin x equals to sin x. So f of cos x, sin x cancel, 1 by cos square, that is sec square x. So look it again, cos square x, f of cos x into minus sin x equals to sin x. So sin x cancel, f of cos x equals to 1 by x square. Now this is, we can write 1 by cos square x. So f of j, what is f of j? 1 by z square. So z is replaced by this. Now we need f root 3 by 4 equals to 1 by root 3 by 4 whole square equals to 16 by 6. So now we consider problem number 5. So rest are your answers. So consider problem number 5. So these are very simple problems. Now look, problem number 5. Fx equals to 1 plus 1 by x 1 to x ft dt. This is dt obviously. So we can write it x into fx, x 1 to x ft dt. Now look, multiplying it by x. So again, differentiating with respect to x. So x into f dash x plus fx. Derivative of x is 1 and x is replaced by x. So fx, derivative of x is 1. Since lower limit is 1, so it is minus 0. So f dash x equals to 1 by x. Now, so what is fx? Integrating, we get fx equals to log x plus log x. Now you have to calculate. So see, by using condition. Now look, no condition is given, but if we put x equals to 1 to the given relation, what we are getting? f1 equals to 1 plus 1 by 1, 1 to 1 ft. Upper limit, lower limit same, so f1 is 1. So value of f1 is not given directly, but we can find value of f1. So what is f1? So f1 equals to 1. So 1 equals to log 1 plus log c. So what is log c? Log c is 1. So fx equals to log x plus 1. So that is log of ex. Log of ex. 1 is. Now we have to find f1 by 2. f1 by 2 equals to log 1 equals to. So what is f1 by 2? f1 by d equals to 0. Now we consider second type of problem. These are difficult ones. Look, these are problem of hierarchy. Look, problem number 8. If fx be differentiable function such that fx equals to x square plus 0 to x e to the power minus p f of x minus p dt. Find fx. So what is fx? So we write fx. fx equals to x square 0 to x e to the power minus p f of x minus p e to the power minus p f of x minus p. So look, this one is not function of single variable. This is function of two variables here. So our main aim will be to express it in terms of single variable. So look, x square. If we replace t by upper limit minus x, so e to the power x minus, and this is ft. Now look, it is in terms of integration in terms of dt. So e to the power x is a constant here. So 0 to x, we can write it e to the power minus x, e to the power t ft. Now this equals to x square e to the power minus x outside 0 to x e to the power t ft. Now this is our main n. Within this integer, it is function of single integer. So this is fx. So now we differentiate it with respect to x. So differentiate it with respect to x. So f dash x equals to 2x. Now e to the power minus x unchanged. Differentiation of e to the power x fx. T is replaced by x, so derivative of x is 1 plus e to the power minus x into minus 1. Derivative of e to the power minus x, and this one is e to the power t ft, e to the power t ft. Now look, so finally f dash x equals to 2x plus fx, and what is value of this one? Look, from 1. What is value of e to the power minus x? Fx minus fx. So this is minus 1 unchanged, and this value is from 1 fx minus x square. So f dash x equals to 2x. Now fx cancel, so plus x square, 2x plus. So look, e to the power x cancel. So f dash x 2x plus this one and e to the power x minus 1. So value is x square. So minus minus cancel. So f dash x equals to 4x. Sorry, 2x plus x square. So what is fx? So to find fx, we have to integrate. So fx equals to x square plus x cubed by 3 plus c. Now you have to find what? The constant c. Now if we put x equals to 1 to this relation, so what we are getting? So suppose this is 2. So f1 equals to 1 and this is 1 to x. So this one is 0 because upper limit lower limit set. So what is f1? f1 is 1. So from 2, 1 equals to 1 plus 1 by 3 plus c. So c equals to minus 1 by 3. C equals to minus 1 by 3. So what is our fx? Fx is x square plus x by 3 plus c. Putting value of c, we get value of fx. So this is problem number 8. So listen again. So this one is function of x and t. So using formula of definite integration, x is replaced by upper limit minus x, we can put it in terms of single integration. Now second one, This is also exactly same. So consider third one, problem number 10. So fx equals to, again look, same type of problem, cos x, 0 to x minus t, ft, so this one is a function of x and t. So our main aim will be to express it in terms of single. So x into ft dt minus 0 to x t into ft. Now cos x unchanged, x outside, 0 to x ft dt, and this minus minus plus 0 to x t ft dt. So this is function of single. So now we can differentiate it, differentiating both sides with respect to x. Now what is f dash x? Minus unknown and derivative of this by product. Derivative of x is 1, so 0 to x ft plus x unchanged, and this is fx. T is replaced by x and derivative of x is 1, and second one is x into fx. So x into fx is cancelled out. So what we are getting, f dash x minus sin x minus 0 to x ft dt. So this is ft dt. Now differentiating again, look, f double dash x. So f double dash x equals to minus cos x minus fx. So what is f double dash x? Unchanged plus fx equals to cos x equals to cos x. Differentiating and transferring with yes. So this is problem number. Now finally problem number 11. Now we consider the last problem, this one. Prove that this equals to, what is the value of this? Prove that this equals to pi by 4. 0 to sin square x, sin inverse root t dt. 0 to cos square x, cos inverse root t dt equals to pi by 4. So integration with respect to t, upper limit is x. So it is function of fx. So right, we consider this as capital Fx. So 0 to sin square x, sin inverse root t dt plus 0 to cos square x, cos inverse root t dt. So what is f dash x? Sin inverse sin x, root over t sin x, derivative of sin square x, 2 sin x cos x, minus cos inverse cos x, derivative of cos square x, 2 cos x into minus So this is plus. So sin inverse sin x, 2x sin x cos x, and this is minus 2x sin x cos x. So this is, so f dash x equals to 0. So what is fx? Fx equals to constant equals to c. Fx equals to constant equals to c. Now look, if fx is constant, so look, f1 is constant, f2 is constant, f5 is constant, for any value of x, it is constant. So look, this is sin square x. So if we put sin x equals to 1 by root 2, that is x equals to pi by 4, this is half. Cos square x, this is also half. Both upper limit are same. So that is why we are putting x equals to pi by 4 in 1. So what is f pi by 4? F pi by 4, 0 to half sin inverse root 3, 0 to half cos inverse root 3. So now 0 to half, this is same integration, sin inverse root 3 plus cos inverse root 3 dt. So this is pi by 2, 0 to half, pi by 2 into dt. So pi by 2 into half. So f pi by 4. So what is f pi by 4? F pi by 4 equals to pi by 4. So fx equals to c. So f pi by 4 is also c. So f pi by 4. So fx equals to c. For any value it is c. So what is c? C is pi by 4. So value of fx equals to pi by 4. So this is problem number 11. So what is value of the integral? You look again. This is fx. Most interesting problem. Differentiating, we get f dash x equals to 4. Now integrating, fx equals to c. Now if fx equals to c, so it is constant for any value. You may say, why we are putting x equals to pi by 4? Because at x equals to pi by 4, sin square x and cos square x both have same value. So f pi by 4 equals to pi by 4. Pi by 4, so fx equals to c equals to pi by 4 equals to pi by 4. So these are the application of Leibnitz rule called differentiation under integral science. So to solve rest of the problem, to get more videos of this type, you share and subscribe to my channel. Thank you.